Welcome to Unit 8, and this is going to be Lesson 3's video. We're going to use the proper terminology for the graph of a quadratic function. And again, that graph is called a parabola. If you're in my Period 7 class, you saw that. If you're in the Period 2 class, you had not seen that yet. But the quadratic function's graph is known as a parabola. A linear graph is known as a line. Quadratic functions are known as parabolas. We are going to find the x-intercepts of a graph. Remember, the x-intercepts are where I touch the x-axis of a graph of a quadratic function in factored form. We know how to factor from the last unit, Unit 7. We will also sketch the graph of a function in factored form. Let's begin. Factored form looks like this. Y equals A times x minus B, x minus C. Okay. Now, some important things you need to know about this factored form of a quadratic function. That A is super important. That A is called the leading coefficient, just like it was in Unit 7, the leading coefficient. And the leading coefficient tells us whether it opens up, whether it opens down, whether it's wide, and whether it's narrow. So it tells us four things. It tells us whether it opens up or down. I guess that's one thing. Opens up or down. There's four possibilities. Up or down. Second thing it tells us is whether it's going to be narrow or wide. And the way that I tell whether a parabola's graph will be narrow or wide is how far away A is from 0. Let me draw a picture for you. If I have a number line, and this is where 0 is, the farther A gets away from 0, the narrower the graph will be. So over here, if I have this value, let's say that value was maybe like 8, that would be a narrow parabola. Narrow parabola. If x is negative 1/4, that's going to be a wide parabola. You'll see what I mean once I graph these. The axis of symmetry is an imaginary line that passes through the vertex. And I should fix that. It's not just any line, it's a vertical line. Oh boy. Now I want what's going on here. Imaginary vertical line. Should be taking notes. If you're not taking notes, you need to get a piece of paper and start writing this down. Imaginary vertical line through the vertex. The vertex, visually, this is a graph of a parabola. That's a parabola that opens up. That's the vertex. It's either the bottom of the valley or the top of the mountain. Okay, it's either the bottom of the valley or the top of the mountain. It is the highest or lowest point on a parabola. It's also known as the maximum or minimum value. Okay. Y-intercepts you should know from the first or second chapter. It's where parabola touches the y-axis. And then we're going to call it intercepting. Intercepts y-axis. And x-intercepts, you guessed it, where the parabola touches, intercepts the x-axis. The word intercept is like intercepting a football. We're going to touch it, we're going to take it away, right? All right, so that's the vocabulary. And that took up most of the time here, almost 5 minutes of the video. But this is super important. If you have not written this down, you need to come to class tomorrow, which is Thursday, the 15th of February. You need to make sure you have all that stuff written down and ready to go. Because I'm going to refer to it all here. You're going to see a picture like this. So remember, we talked about all these different things, right? Let's start with this one. This should be fresh in your mind. What's happening right here? The parabola, okay, this thing is called a parabola. That's the graph of the quadratic. It's called a parabola. It's where the parabola touches the y-axis. What is that called? Y-intercept. Okay. Looks like we have an imaginary vertical line that passes through the vertex. What's the vertex? Oh, looks like it's right there. Vertex is that lowest or highest point on the graph. It's the minimum or maximum value. That would mean that this imaginary line passing through the vertex is called the axis of symmetry. And now I hope that you realize why it's called the axis of symmetry. Because it's like a mirror that has symmetry. The left side here is a mirror. If I just take it and I flip it over to this side, imagine flipping it over that line and landing right there. It's the same thing, axis of symmetry. Okay? All right? Now there's 4 names for the thing I'm about to point out. Okay, there's 4 names for the thing I'm about to point out. Right here and right here. What's happening? The parabola is touching the x-axis. There's the x-axis, here's the y-axis. And that's called my x-intercept. Another name we might use is called a root or a solution. Okay, and then the 4th one is a 0. All right, and this is also the same thing. X-intercept is the first word. A root is the other word. Solution or a 0. Okay, so again, a lot of information just thrown at you here. We'll fill out this graph again in class tomorrow, but you need to have watched this video for this to make sense. I'll be a little irritated if you haven't watched the video and have to explain everything to you. Okay, we're going to skip this part. So we're going to graph something here. F of x, which is the same thing as y, equals x minus 5, x plus 1. Now, the first question is, what direction will open? Will I have an opening up, or will I have an opening downward? It'll be up like a cup or down like a frown. The way that we tell is you look at the a value, which would be located right in front up here. And if there's no number there, we can assume that there's a 1, a positive 1. Now, if the a value is positive, this parabola will open up like a cup. And that's because a is bigger than 0. A is positive. Okay? So, the next thing we want to find are the solutions, which are known as the x-intercepts. Now, the way that we find that is we take each of the factors. Once I have it factored completely, I use the zero product property. I set each of those factors equal to 0. Now, you don't need the parentheses around here. They're going to just go away eventually. I just drew another one. Solve by using inverse operations. X is going to be 5, or x is going to be -1. Now, the solutions. The x value will be 5. When I write my solutions or x-intercepts, I'm going to put them as ordered pairs. Okay? Ordered pairs, which means I need an x value and a y value. You need both for this to be correct. Just like when you did intercepts on lines, it needs to have an x and a y value. We know what the x value is. It's going to be 5 and -1. So we have 5 something and then -1 comma something. Now the something I'm looking for is the y value. Now the equation says y equals this. Y equals x minus 5, x plus 1. Now if I put 5 in for x, I get 5 minus 5 times 5 plus 1, which would get me 0. This is going to give me what my y is, by the way. It'll give me 0 times 6, which is just 0. So my y value, and this is going to be 0. 5 comma 0 would be my first solution, or x-intercept. So over here is my x-axis. I'm going to go by ones. 1, 2, 3, 4, 5. My first x-intercept is right there. Let's put -1 in. Okay, so I'm going to solve for y in this one by putting -1 into the equation. Y equals x minus 5, x plus 1, put -1 in for x. Y equals -1 minus 5, that's going to be -6. -1 plus 1 is going to be 0. I have -6 times 0. And again, I get 0. So my y value for the other solution is 0. Are you noticing a pattern? When I am on the x-axis, when I have x-intercepts, what should my y value be? It should be 0 every time. Those solutions are ordered pairs. Should have your x value from here, from solving, and the y value should always be 0 on those x-intercepts. Now, to find the axis of symmetry, the axis of symmetry is going to be a vertical line. The equation of the axis of symmetry is always, 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 in this class when we're graphing parabolas, going to start as x equals. Now to find the axis of symmetry, I need to find the middle between these two x-intercepts at -1 and +5. To find the middle, 1, 2, 3, 4, 5, 6, half of 6, 1, 2, 3. There it is. What x value am I on? X equals 2. Okay? There's my axis of symmetry, and I just drew it. Now to find the vertex, what I have to do is take this value, this 2, and plug it in to the equation for x. So I'm going to draw a little line so you get my drift over here. Y equals, and it was x plus, minus 5, x minus 5, x plus 1. And so then I just plug that 2 in for x, because that's what the axis of symmetry was. 2 minus 5, 2 plus 1. All right, 2 minus 5, -3. Don't screw this up. Use a calculator. If you can't add or subtract, first of all, fix that. Second of all, use a calculator. -3 times +3. Again, you better be able to multiply that. Or if you can't, use a calculator. No excuse to get problems like that wrong, unless you're just lazy and you won't type it in. So y is -9. What was x? I know y is -9. What was the x value? Well, it's what I plugged in for x. It's 2. 2 -9. So over here, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. There's my vertex. The last step. Now I know this is going to open up like a cup. So it's going to look like this shape up here. It's going to swoop up like this. And you kind of can see the shape starting. You can visualize where my cursor is, where that yellow circle is sort of bobbling around. That's where my parabola should be, but I need to fill in another point. So we need to plug in one more x value. Okay? Let's plug in one more x value. It can't be 2, it can't be -1, it can't be 5. Let's pick one that's close to where we want to graph. Let's pick +1 for x. If I put 1 in for x, put it into the equation. Y equals 1 minus 5, 1 plus 1. So y equals 1 minus 5 is -4. 1 plus 1 is 2. That's -8. At 1, I have -8. There's the point. Now guess what? This is an axis of symmetry. It's like a mirror, which means that once I plot a point on the right side of it, I'll have another point exactly the same distance over on the other side. Actually, I did that backwards. This is 1 -8, and this is 3 -8. The other point I got was 3 -8. And now if you connect those dots, you will get a parabola. Now look how I'm doing this. Do you see how I made a nice smooth curve and it went up like that, has an arrow at the end? Don't just do this. That's not acceptable. You're going to take your pen. I can't do this either. Not good. It needs to touch all those points. You need to follow through and go all the way up. Okay, just like that. Another thing I don't want to see. I don't want you to get lazy once you get to the end of your points, okay? Oops, I hit it too many times. What's happening? There we go. So there are my points again. I can see you do this, but I don't want to see this. Don't get lazy at the end and go boom. No, not good. Don't do that. Okay, let's try that again. Swoop up through the points, nice and easy. Looks like a nice little U, almost a V because it's kind of pointy. And there you have it, my parabola, sketched out. We'll do more examples in class. If this doesn't make sense to you, do something about it. Don't just say, well, I don't get it. Come talk to me. Watch another video. Watch this one again. Talk to a friend. I'll see you tomorrow. Have a good evening.